shear stress or shear strength is lower than normal strength or normal than normal strength. Right? In shear, the values are lower. So let me quickly go into a look at a textbook. Okay, if I can get into the textbook to show you some values. Okay, so if you look at the textbook, the last few pages, we have material property, right? So you can see here, like moly alloy, where my cursor is now. Okay, 400 nickel copper. You see the tension is 585, and the shear is what? 345. Can you all see that? Right? Or the next material down is at 220 normal stress, and the shear is at what? 125. Okay, so in general, what you tend to see is the shear stress magnitude is lower than tensile, right? So if you were to go back to our problem over here, if you were to calculate just using 2D Mohr circle, you have underestimated the what? You just use 2D Mohr circle, right? So I'll write down here. So with 2D, in plane, right? Tau max is equal to 15 MPa. 3D, right? Tau max is equal to 30 MPa. Okay, so that's why it's so critical to analyze structures in 3D configuration. Okay, this is so critical. Okay, so not just in compound loading that I've just tested you in term test 2, right? 3D Mohr circle, we have to analyze using the 3D, using or material selection. We have to use 3D Mohr circle. Okay, now I'm going to come and construct condition number 2. Okay, so far, anyone, any question? Let me look at the chat. Anyone, any questions so far? None. Okay, so now we're going to look at condition number 2. So before we go on, condition number 1 is where stress X is greater than stress Y. Both are positive. Stress Z is equal to 0. Then next we go to condition number 2. Okay. So condition number 2 is such that stress X is positive, stress Y is negative, rather than comma, and stress Z is equal to 0. Okay, so we're going to use this condition now, where stress X is positive, stress Y is negative, and stress Z is equal to 0. Okay, so now I'm again going to do 2D Mohr circle. Okay, and then we're going to look into 3D Mohr circle. So this condition is slightly different than the one before. So this is X, this is Y, and then we have our element, right? So stress X is equal to 40 megapascal. Then it's compression of 25 megapascal. Okay, And then if I'm going to draw this in 3D world, X, Y, and Z, right? This is equal to 40, and then this is equal to 25 megapascal, and the stress Z is equal to 0. So I label the points again, surface relative to Mohr circle points, X and Y. This is your point X on Mohr circle, point Y, because it's 3D, you have your point Z, and with this, we know that stress Z is equal to 0. Okay. So now we construct 3D Mohr circle, or 2D first. Okay. So this has tensile and compression. So I'm going to have minus 30, 20, 10, 0, 10, 20, 30, 40, normal stress. Then we have our shearing stress. Element rotate clockwise, element rotate anti-clockwise. So this is 10, 20, 30, 40, minus 10, minus 20, 30, minus 40. So our stress X line is at 40. Okay, and then our stress Y is at minus 25. And then this is our stress Z line. So this will be our point X. Let's do 2D Mohr circle first. And this is our point Y. So from here, we can construct our circle. Okay. We can construct circle. On. I know it does not look circle. Okay. Okay. So now this is just using 2D Mohr circle. Okay. So this is our XY plane. And the normal stress max is equal to 40 megapascal, right? The minimum stress is equal to minus 30 megapascal. Okay. So this is just using 2D Mohr circle. Okay, 2D Mohr circle. Okay. Now for this case, 2D Mohr circle is sufficient. What do I mean by that? Okay, because it's going to generate the biggest circle. Then I'm going to draw the other two circles to do 3D analysis or 3D Mohr circle. So we know that this is our point Z. Okay, 2, 4, 5. Then this circle over here belongs to our YZ plane. And this is our out of plane. Pardon me, this one XY plane is our in plane, right? So with that, we realize that the maximum shear stress over here, our maximum shear stress over here as you can see is only at 15 megapascal, right? So this is our shear max YZ, okay? The one that we have drawn earlier. This is the biggest circle, which is our XY, and this is what 40 plus 25, 32.5. And this is our tau max, and our tau max for our case now is the in plane one. Okay, right? So the out of plane one, the YZ, is only 15 megapascal in shear, and the third circle, right, is only 20 megapascal. Okay. So this is your XZ plane, which is out of plane. And you realize that normal stress max is equal to 40, but the shear max is only equal to what? 20 megapascal. Okay. Okay. So this is over here. Let me draw it out. Here to here. All right. So this is tau max. Tau max. XZ, and this is only equal to what? 20 megapascal, right? And this is for your XZ plane, right? And your maximum stress Oh, I think this is enough. Yep. Okay, I've all written in red down here, right? The maximum normal stress is 40 megapascal. Okay. So what you see over here, right, is again, for this case, your tau max is equal to what? 32.5 megapascal. And you can get that answer by just constructing 2D Mohr circle. Okay. The previous example which you see, right, the maximum shear stress you have to use using what? 3D Mohr circle. Okay. So we just discover when to use 2D Mohr circle and when to use 3D Mohr circle, or when you can use 2D and when you cannot use 2D, you have to do 3D. So in cases where stress X is positive, stress Y is negative, stress Z is equal to 0, you can use 2D Mohr circle. Okay. Whereas in the previous condition where you have stress Z and stress Y, or stress X is greater than stress Y, both are positive or both are negative, and stress Z is equal to 0, you have to use what? 3D Mohr circle. So the third condition that we have, so first condition is stress X is greater than stress Y, both are positive, stress Z is equal to 0, condition number 1. Then we just completed condition number 2, where stress X is positive, stress Y is negative, stress Z